So we have another example to determine whether these are inverse functions. So we're going to check the f of g of x, which is looks like this. Okay, the first thing we're going to do is plug in g of x, which is over here. Okay, so that's going to be 1/3 x minus 3. I'll bring down my f. The next thing you're going to do is evaluate the function. So this is go to the f function, which is right here, and write it down. So I'm going to write 3x plus 9. 3x plus 9. That's going to be represent my f of x function. And then everywhere there's an x, I'm going to plug this information in. So we're going to say 1/3 x minus 3. 1/3 times 3 is x. That gives me minus 9 plus 9. So in this case, we did get x, and that's what we were looking for. That's what we were hoping for if these were going to actually end up being inverses. But now we must test the g of f of x, which is this form. And the first thing I'm going to do is plug in f of x. That is this 3x plus 9. Bring down the g. This notation tells me to go to the g function and write it down. So I'm going to say 1/3 x minus 3. I write this function down except for everywhere x is out, I put a parenthesis, and then I'm going to plug this in place of x. Distribute. 1/3 times 3 is x. 1/3 times 9 is 3. And then 3 minus 3 is just x. So because the f of g of x equals x, and because the g of f of x equals x, therefore these are inverses. And so now we look at a relation and we say, is the function 1-to-1, find its inverse, or is this relation 1-to-1, find its inverse? So the first thing we would say, yes, it's 1-to-1. Because every x value, well, I'll write it because every x value corresponds to only one y value. Okay, and then it says find the inverse. Well, if this is -2, 1, the inverse is 1, -2. Good. If this is 4, 3, the inverse is 3, 4. If this is 0, 5, then we have 5, 0. So this represents our inverse. Alright, now let's look at B. And the first question is this value 1-to-1? Well, I'm going to look at my x values, 1, 2, 3, 4, 7. Alright, and then corresponding y values. I'm looking at -2, 4, -2. Whoa, I need to go back and check this out. I have -2, and then I say 1 corresponds with -2, and 3 corresponds with -2, so I'm going to say not 1-to-1. I don't need that. So this is not 1-to-1. Because every x value does not correspond to only one y value. Okay, so it does not have an inverse. So not 1-to-1. So it does not have an inverse. So we pretty much just looked at inverses for some ordered pairs and some relations up here. Now we're going to be actually given a function and then asked to find the inverse. And there's a little bit of a process of this, and if we find the equation of the inverse, the first thing we're going to do is interchange the x and the y, solve for y, and then we're going to replace y with f inverse of x. So let's see these steps. First thing, I want you to recall that function notation f of x means the same thing as y equals. And we're actually more familiar with this form, but we need to be able to interchange back and forth. Our first, our first step right here is going to be interchange the x and the y. So we're going to say, we're going to let that become the x and this become the y. So simply interchange the x and the y. Our next step says solve for y. So if I want to get this by itself, I'm going to subtract 4 from both sides. And I would get x minus 4 is equal to 2y. And then I'm still trying to get y by itself. So divide both sides by 2. And I would have y is equal to x minus 4 over 2. And this would be the inverse. Actually, we have one more step. So we did this and we did this, and the last step is we want to replace y. So let me take this down. We want to replace y with f inverse of x. So the last step, all we did was replace this with our f inverse notation, and then we say we're done. Okay, so let's see one more. We're going to do D the same way. We're going to use this three-step process, and we're going to see one more. So the first thing we're going to do is rewrite, it's already in y equals, so we want to interchange the x and the y. So x equals y squared plus 5. That's step 1. Interchange the x and the y. Step 2 says get y by itself, so solve for y. If I want this by itself, I need to subtract 5 from both sides, so I would get x minus 5 is equal to y squared. And then to get y, if that's a square, I'm going to have to take the square root of both sides. Remember, when you take the square root of anything, you're going to get plus or minus. X minus 5 is equal to y. Now my last step is I want to interchange this y with f inverse of x notation, and then if y is equal to this is going to be our inverse, so it's going to be plus or minus the square root of x minus 5. This will be your inverse. And let's see one more just so we can kind of get familiar with different forms that we might possibly see. First thing we want to do is rewrite this with our y notation. So y is equal to x plus 2 over x minus 1. And this just tells us that, of course, we can't have 1 in the domain because 1 minus 1 would be 0 and our function would be undefined. So this just says, don't forget, x can't equal to 1. So now we're ready to go ahead and interchange the x and the y. So interchange y plus 2. Everywhere there's an x, we're going to replace it with a y and vice versa. To solve this, it's probably easiest to cross multiply. So this would give me x times y minus 1. And over here we would get 1 times y plus 2. So we're distributing here, xy minus x is equal to y plus 2. Alright, so at this point, our goal is to solve for y. So I need to get all the y terms, which would mean this one and this one all on the same side, and everything that doesn't have a y, I need to move it to the other side. So I'm going to say xy, I'm going to leave this one here, and then I'm going to subtract y. So if I move this y to this side, it becomes minus y is equal to, and now I need to move this x over here, so it becomes plus x, and this 2 is just going to drop down. So right there, I just kind of switched things around, and anytime you cross the equal sign, you change sides. But I need this y term, I need this term, and this term to be on the left, and I needed everything that did not have a y in it to be on the right. So that's kind of what we did. Now we're still trying to get y by itself, so I'm going to say they both have a y in them. I'm going to factor a y out. If I take y out of this term, I have an x left. And if I divide a y out of this term, I have a 1. And this side I just bring down. To get y by itself, I'm going to divide both sides by everything in that parenthesis. So divide by x minus 1. And then this cancels this, and I get my y equals x plus 2 over x minus 1. In our last step, as they say, replace the y with our f inverse notation. So this will be our inverse, and that one was a lot more complex than the previous two. And we want to recall that x cannot equal 1. Still, we need to make that statement, because if a 1 was there, we would have 0 in the denominator, and it would be undefined.